Charlie asked a few years ago why we think there are atoms if we can't see them. Well, we actually can now see the trails made by pieces of atoms using a cloud chamber, and our main scientific instrument will be a plastic cup. The star of the show will be the debris from a fairly mysterious creature called a cosmic ray. We're not sure where they come from other than outside of our solar system, because they occur all the time, not just when the sun is up. We think they are protons, maybe made by supernovas, maybe black holes, maybe something else. Wherever they come from, they are moving at close to the speed of light when they smash into one of the molecules in our upper atmosphere. This creates a shower of particles called muons, which is like a fat electron, and those go whizzing toward the bottom of this cup, hopefully. And there we will see kind of a thick, straight track at the bottom. Co-stars will be alpha particles, which are emitted as part of a natural background radiation. Smoke detectors depend on this. These are helium nuclei. They'll show up as a short, thick track. Also, stray electrons, which have been kicked loose by muons and alpha particles, will show up as thin, erratic trails. By the way, the life of a muon is very short and shouldn't be able to make it to this cup, but thanks to Einstein's special theory of relativity, its internal clock slows down so much that it's able to make it. Thanks, Al. Here's our strategy. We're going to try to fill the bottom of this cup with alcohol vapor so dense that when these particles go tearing through the vapor, they will leave an easily observed trail as the alcohol condenses around it. So at the top of this cup, we're going to pour isopropyl alcohol into something absorbent. This vapor is heavier than air, so it will drift down to the bottom of the cup. Then we'll use dry ice, which is minus 109 degrees Fahrenheit, to drop the temperature so much so that at the bottom of this cup, we'll have the air in what's called a supersaturated state. I kind of think it's similar as to why there's so much moisture in the morning on windows and so forth if you live in a humid climate. As the air cools overnight, it has more water vapor than it can deal with, so condensation happens very easily. In the case of our experiment, the alcohol starts out in a pleasant morning in Hawaii and ends up in a bad winter in Antarctica, so in the space of about 6 inches. That's also why we are using alcohol instead of water vapor, as the freezing point is even less than that of dry ice for alcohol. Okay, what do we need? First of all, if you Google do-it-yourself cloud chamber, you'll get a lot of videos. So if something's unclear or you don't like the way I'm doing it, then you've got a lot of alternatives to go from. But 32-ounce clear plastic cup. And what I've done is I've cut felt into these little circles. I did about a dozen of them. And you can use cut out a sponge. I've seen that done, or anything else. But what we're going to do is we're going to cram it inside this cup. Okay, so now it's stuck in there. But the thing is once you add alcohol to this is going to get heavy. So you got to have something that's going to wedge whatever you're using to absorb the alcohol. You're going to have something that will wedge it in there. And what I use are these neodymium magnets. This happens to be like 3/16 of an inch in diameter and a 1/2 inch long. There's nothing magic about this. It's just what I happen to have around. And so what I do is I use pairs of them to kind of make sure that they're wedged in there. Okay, so if you can see now, got 4 on the outside matched with 4 on the inside. That's gonna stick in there pretty well. Next is the isopropyl alcohol. You can use anything that's over a 90% isopropyl alcohol. I've used 99%. I find this occasionally in pharmacies and grocery stores. And I've also used 91%, which you can always find that. If you use 70%, that's probably too much water in the alcohol, and so I'm assuming, I've never actually tried it, but I'm assuming what you'll get is ice at the bottom of your experiment as opposed to vapor, and we don't want that. Next, you're going to want something that's good at transferring the heat away, which is basically a skillet or a frying pan. I happen to use this 6-inch cast iron skillet. I figure that's a pretty good at transferring heat one way or the other. Okay, this is actually very important. And that is, once you have the alcohol soaking in the cup and the dry ice ready, you will need to seal the rim of the cup to whatever you're using, whatever pan or piece of metal or whatever that you're using to put on top of the dry ice. And so I use this stuff, which I think is the third greatest invention of man. First there was fire, and then there was the lever, and then there's this stuff called sticky putty. And I use this for everything, and in fact I use it to put around the rim of the cup so that I can then put it down on the pan and I'll get a good tight seal. If you don't get a good tight seal, then the outside you'll see little puffs of clouds come in at the bottom, which is not what you're after, and kind of spoil the experiment. It's better to do this in a dim light, and therefore, and the reason is you can use a small flashlight to reflect the trails off the condensation back to your eye, and that's better done in dim light than in a bright room. But if you use too intense a flashlight, it just washes everything out. You can't see anything. So I use one of these little pin flashlights to observe the tracks at the bottom of the cup. A few kind of optional things. I try to heat the very top of the cup a little, and just to warm it up, with the idea being that it would create more vapor. And what I usually do is I put one of these little gel pads in a cup of tap hot water. I don't do anything special, just run the hot water until it gets as hot as it can. I put this in there for a couple of 3 minutes and then put it on top of the cup. I put the dry ice in a baking pan. Probably not necessary, but I do. It will sort of, especially if you're in a humid climate, it's going to create some condensation. And then I usually put a blanket around whatever part of the dry ice is exposed, in the hope that provides a little bit of insulation and keeps it around longer. A few things about the dry ice. So far I've been able to locate grocery stores which carry a brand called Penguin, and I can get a slab that's about 2 inches thick and 12 inches square. I usually put it in a picnic cooler until I'm ready to use it. Don't put it in your freezer because it will just confuse your thermostat, apparently, and won't do much good anyway, since your freezer's at 0 degrees Fahrenheit and this thing is at minus 109 degrees Fahrenheit. I'm not sure. I don't know how long it will stay in the picnic cooler, but once you have it out and you're using it, it will effervesce away in about 18 hours. Okay, when we go to add the alcohol, the idea is that you pour enough into it to where, to me at any rate, you do enough to where it just starts to leak over the side. Just let it soak in, and you just keep doing that. Okay, that got about 75 milliliters or so, and I'm going to pour the excess out. And now we need to flip it upside down on the pan. Doesn't matter if it gets a little bit, and then we really press down. Really press down to make sure you get a good tight seal. Okay, got a tight seal. We're ready for the dry ice. As you can see, the gloves are coming out. Might be good to have glasses on too. You don't want a stray chip of something that's minus 109 degrees Fahrenheit flying in your eye. I don't know why this is such a good fit, but it is. Now we put the pan on top of it. Nice little noise as the cast iron goes, whoa, that's cold. And now I'll put the blanket around the exposed dry ice. And then lastly, I put this little gel pad on top. And now you wait for about 10 minutes for things to sort of kick in. When you're done, there's one other fun thing you can do. Cover up the dry ice, put a glove back on, take a couple of whacks at it, and get yourself a chalk and pretend you're a mad scientist. I just think that's fun. I don't know why. That's all I got. That's a way to see what the universe is doing around you when you don't think it's doing anything. I wish I could show you how 65 billion neutrinos are passing through your thumbnail every second, but the neutrino is a notoriously shy particle and very difficult to detect. So, hope somebody tries this and has fun with it.